Okay, today we're talking about multiplying polynomials. On Friday we talked about multiplying binomials. And what was that method, Nick, that we used for multiplying binomials? FOIL. We're going to go over 3 methods today. 2 of them are review. The third one is technically review as well, but you're going to be like, wait, we haven't done that before, but we actually have. So the third one I'll talk about FOIL more. But what kind of polynomial do I have first? Trinomial times a binomial. So the first way I want you to review it is simply by using the that's not going to work. We're going to call it's the rectangular box method. I'm going to call it from here on out the tabular method. Tabular, because you have tabs. So we'll call it. And we're going to go with a 3 by 2. Wow. So we're going to put the trinomial up top and the binomial on the side. Okay, now listen to me carefully. This could have been written in a different way. And you don't have to write this, but it could have been written in this way. You put the binomial and the trinomial on the side. Either way is going to work. It's the same thing. But let's go ahead and do this together. What's x times x squared? X to the third power, x cubed. What's x times 4x? 4x squared. What's x times negative 12? Negative 12x. Okay, so you get those 3 products. And again, you've done this before. You did it with just binomials, but it's the same thing with trinomials. You just have an extra 2 products. What's 4 times x squared? 4x squared. What's 4 times 4x? 16x. And what's 4 times negative 12? Did you guys notice there was a lot of multiplying? I did. Okay, and 7th grade, even beyond, before that, remember you had to learn multiplication tables? Because if I'm looking at 4 times 12, I'm thinking 48. So if it takes me that long to get 4 times 12, that's only one part of the whole problem. And so you see how I'm getting bogged down just thinking 4 times 12. 48. I got it, but it took me a long time, and that makes the whole problem take a long time. So memorize your facts is what I'm trying to get at. Okay, then when you have your 6 partial products, you realize that you have a pair right here that are like terms, and these 2 are also like terms. So I get x cubed first. It's the highest one. What's 4x squared plus 4x squared? 8x squared. 8x squared. It doesn't have to, but it's nice when you read it that way. And wasn't it nice that they wrote it that way for you? Yeah, so I do it standard form. You should get used to that. What's 16x plus negative 12x?
Well, wait, if they write it in standard form, it's always going to be, like the top row is going to be in standard form and the bottom.
Yep. And that's because they wrote it. So like if you're like, I hate standard form, I don't really like it. Well, you write it non-standard form, then you get all these numbers mixed up, and you can't do it this nice, clean way. And then minus 48. Okay, so you got this right here as your final product. Say that again? No, that's okay. Did you get? Oh yeah. What's 4x squared plus 4x squared? I have these 2 like terms. I get 8x squared because I add those 2 together. And then what's 16x plus negative 12? What's 16 minus 12? 4x. So I'm just combining like terms. These were like, and then these 2 were like. Okay, ready? That's the tabular method. So I'll say, all right, use the tabular method. Use this little rectangular box. I want you to write this one. It's the same problem, by the way. But we're going to use the vertical format. What was the second binomial? X plus 4. And we're going to multiply this vertically. And I'll put this little x in parentheses so I know that's multiplying. And we did do this on Friday. And maybe some of you are kind of shocked by it because like, wait, what's going on? You multiply it just like you did any other numerical problem. So write this down. I have a trinomial, 3 terms, and a binomial, 2 terms. So this is what I do. I'm going to multiply this term by each one of these. What's 4 times negative 12? Negative 48. I wrote this for, I don't know if this is going to help. What color? Pink. That might work. I did 4 times negative 12 is negative 48. What's 4 times 4x? And then I'm going to do 4 times x squared. So again, 4 times negative 12, negative 48. 4 times 4x, 16x. 4 times x squared, 4x squared. So that's what I got up top. I just multiplied the 4 by each one of those. Yes, ma'am?
When you're going to do x, do you need to add the placeholder, the 0?
Yeah. Okay, so I got the first row done, so this times all 3. And now I'm going to do x times these 3. So what's x times negative 12? So I'm going to write that right here, not only because you could think of a place value holder, but what else am I trying to do here? What am I I'm trying to line up like terms, yeah. So you can think of it. But there is a 0 here that you leave alone. So you did x times negative 12. You're going to do x times 4x, and you're going to do x times x squared. Sorry?
Attention, faculty and staff and teachers. We are on a soft lockdown. You may move about in the building, but please do not leave the building until further notice. Thank you.
So that's soft lockdown. So that means we can if the bell rang and we need to go to class, you can go to class, except if you had to leave the building. So none of you have to do that for next class because no PE. So yeah, it's a drill, but you'd act like it was normal. Yep, we heard it perfectly. Thank you. So like, if this were first hour on Monday or Wednesday, or excuse me, Tuesday or Friday, you're up there at the PE, doing your PE thing. You could have to stay there until the soft lockdown is over, or you'd have to stay here for the soft lockdown. And yeah, that makes things confusing, but that's for your safety. Okay, what's x times 4x? 4x squared. So I got that. And what's x times x squared? X to the third power. I have 2 partial products. I'm just going to add like terms, and I get something I've already gotten before. I get the same product. Now, how many of you are getting more comfortable with vertical method? Because I introduced it, Friday? And then some of you are like, oh, it's okay. Some of you wanted to use this method. I'm okay with that. I don't mind this method. How many of you are better with this now? Sorry. A couple of you, a few of you. Okay. You're going to have to know how to do it too. So be ready for that. But there is a third method. And I'm going to go through it with you guys, but I want you to tell me what the method is called. Let me give you a hint. So write that down, and I'll show you what it is.
Oh, Davis got it.
I don't know what people were saying. I heard a couple things. So FOIL, distributive property. Anyone else?
I said horizontal.
Horizontal method. Okay, let me go back.
Uh-oh.
When you did this problem here, this is what actually happened. Okay, I'm going to draw a lot of arrows. You don't have to draw these arrows on here. But didn't I multiply x squared by x and by 4?
Yep.
Okay. And then didn't I multiply 4x by x and by 4? And didn't I multiply negative 12 by x and by 4?
Yep.
How many times did I multiply?
1, 2, 3, 4, 5, 6.
6 times. And I did it 2 here, 2 there, 2 there. Okay, that's what I did on the first example. On the second one, I show you when I multiply these 3, but didn't I also do this? So I multiplied each one of these by all 3 of those, right? So I did 4 by all 3, x by all 3. So how many multiplications did I get? 6 of them. And then I combined like terms. This method right here is actually called the distributive property. But all of them are distributive property, just in different forms. Okay, ready? The distributive property looks like this on this problem. You're going to multiply the first term here by both of those terms in the other polynomial. What's x squared times x? X cubed, x to the third. What's x squared times 4? 4x squared. So all I did is multiply that term by both of those. Now, actually, I'm going to pause here. How many of you remember FOIL? First, outer, inner, last. This is a trinomial times a binomial. Let's try FOIL real quick. Let's just see if it works. Don't write anything. First would be these two, right? Is that true? Okay, outer would be those two. And I got that so far, right? I got those so far. Inner, what do you think?
Negative 12 and x.
Okay, these two. Negative 12 and x, I'm fine with that. And last,
Negative 12 plus 4.
negative 12 plus 4. What term hasn't even been touched?
4x.
This 4x. So it's almost like it got dropped out, but is that going to be sufficient? No, because FOIL, how many times do you multiply in FOIL? 4 times. How many times do you have to multiply in this problem? 6 times.
So you can do FOIL, then you just have to multiply the middle one.
Yeah, I mean, you could do that. You're like, all right, I got to do 4, but then I got to remember this one. But what happens if you have 3 and 3? Then you're like, you're having to account for that one and that one, but that's actually, you miss a few more multiplications than you thought. Okay, I multiplied x squared by both of these. Now I'm going to multiply 4x by both of these. What's 4x times x? Another 4x squared. So we got a similar one there. What's 4x times 4? 16x. So I multiplied the second term by both of those there. And then what's negative 12 times both of those? What's negative 12 times x? Negative 12x. And negative 12 times 4? Negative 48. And those 6 products were already in the other 2 methods. Do you remember? We had 6 products in the tabular method, and we had 6 products in the vertical method. Add like terms, we get x cubed plus 8x squared.
Plus 4x.
And by this time, I hope you realize that we've done it 3 times, so we should have this.
So we wasted our time?
We have this product pretty much memorized. All right, this method is called using the distributive property. This method is called vertical method. This method, we call it now the tabular method. Any questions on what they're called? Oops.
What does tabular mean?
Because they have tabs, like each box is a tab. And if you think of like when you're using Word documents, you press tab. And if you had a little chart, it'd go from one to the other. Or Excel, sorry. Excel's probably the better one.
I Excel.
I think I know him.
It's like a dog when it sees a squirrel. He's not supposed to be outside.
What's his name?
Mr. Beal to us. He went with us on the Cherokee trip last year. But he's not coming with us this year. But he did go last year. Very nice guy. Okay.
So he's not a student or teacher or faculty, right?
No, he's a church staff member.
So that means that's why we're having.
He is allowed to be outside. Yeah, because I don't think they have a lockdown. Okay.
Is there a
Or something.
Yeah.
in the area?
It's a drill.
All right, let's keep going here. I want you to use the tabular method, and I want you to use it this way.
No, that's so much harder than that. Oh, Mr.
It's not complete.
We just were kidding.
Okay, go ahead and work on this problem here. So that means you're going to put the binomial up top and the trinomial on the side. And then I'll call on different people to give me different parts of this.
When I need to put the side one
Say that again.
Ooh, shot fired.
You can write it here? Yeah, you can do that. Either way, just make it, what I'm looking for is those 6 different products, partial products that have to be correct. All right, Nick, what should go in this spot right here according to my tabular setup? 2x to the third. Okay, that's right. Caroline, what should go right here?
Sorry.
That's okay.
Negative 3x.
Negative.
Oh, sorry. Wrong box.
That's okay. And you can look at what mine is right here.
Okay. Negative 6x to the second.
Yep, negative 6x squared. Rachel, what goes in this box?
Negative x squared.
Mm-hmm. Matt, what goes in this box? In this case, it'd be positive 3x because you have a negative times a negative. Just be careful with that. By the way, on the homework on the last class, I kind of flipped through theirs, and they were getting these numbers all right, but when they added like terms, for example, are these 2 like terms?
Yeah.
Yeah, so they put negative 1, negative 6, and they got positive 7.
What?
And so the number was good, the 7 is good, but it's negative 7, not positive.
Same exact thing. When you just said that.
2 times x. And then 2 times negative 3. All right, and then if you set this up, standard form, what's nice, again, these are like terms, those are like terms. What's my final answer, Davis?
It is 2x minus 7x squared plus 5x minus 6. Did you say 2?
Plus 5x minus 6. All right, there you go. And that's standard form, which is nice. Nice for you, nice for me.
Yay. Wait, how is it nice for us?
Because remember, you're going to get problems that when you get this answer, you're not done.
So it's like, right at what?
Because there's more like terms.
There are many like terms. You have to find x.
Use the vertical format. Oh my, that's a trinomial times a trinomial. Oh my. So here's your problem. And this little multiplication sign has a parenthesis showing that it's not part of the actual problem, but we're just multiplying just so you know what to do here.
Wait, it's not the same problem.
No, it's a different problem. Yeah, because I want you to do it all 3 methods. Here, can I see it? You're going to start with this one, negative 3, and you're going to multiply negative 3 by this, and by that. So, and then you're going to take this one, multiply this term by this, and that. Then take this term, multiply by this, and that. So you should have 9 different little answers, and then combine like terms. So using the vertical method, as I was telling someone, you're going to have 9 different terms when you multiply that all together. Then add like terms if there are any.
Oh my. So like third, like the 2 into the second, would you put the third place value? Would it be 2 place value?
Yeah, you'd have to do, because you did these 2, you mean? Mm-hmm. So you should have blank, blank, and then do the next one. Yes, sir?
Does it matter like what order you combine them in?
Yeah, you want to do a standard form. So you want to do the 4th, 3rd, 2nd.
Can you take one from like the top row and then like the bottom row and combine them if they're like terms?
If they're like terms. Any like terms could be added, yep, no matter how they're written.
What property?
Okay, I'm gonna call 3 different people. The first person is gonna give me what -3 times all those are. The next person -3n times all 3 of those, and then last person 2n squared times all 3 of those. All right, I'll go with Emma Grace. So -3 times 6. -3 times 2n. -3 times n squared.
-3n squared.
All right, great. Those are your first 3. Second person, Wyatt, you're going to give me what -3n times 6 is.
-18n.
-18n. -3n times 2n.
-6n second.
Good. And -3n times n squared.
-3n to the third.
-3n to the third. All right. And yeah, I'm going to squeeze a little bit there. And last person, John. So what's 2n squared times 6?
12n squared.
12n squared. What's 2n squared times 2n?
4n to the third.
4n to the third. And then what's 2n squared times n squared?
2n to the fourth.
2n to the fourth.
Wow.
Yep. So I squeezed it in there, but thankfully we're able to get it. Okay. I should come up with 2n to the fourth plus n cubed. 9 plus 3n squared minus 24n minus 18.
I got 7.
7n cubed.
Oh, it's
Oh,
negative.
yeah, it's a negative plus a positive. Questions. How many terms does your answer have? 1, 2, 3, 4, 5. It's a 5-term expression. And that's the final answer, as small as you get.
I got that. Let's go.
Yes, yeah, because each one of these is part of the answer, and they're unique. All right, how many of you got the 5? How many of you got it in that order? Okay, good. So you got the order. If you didn't get it, because there were a few of you, and don't feel bad if you didn't get it. Are there any questions? Like you didn't get maybe this one, or you didn't get 2 of them, you didn't get one of these numbers, please ask. Or forever hold your peace. All right, fine.
Uh-oh.
You guys are all ready for this next one.
No, I'm not ready yet.
I want you to use the distributive property. Okay, I don't think we've done this one. All right. On the homework, we'll actually say use one method or another. All right, there you go. Distributive property. Yeah, you can have a trinomial, and trinomial all being multiplied. You get those first 2, multiply them out, and then take that, and multiply by the third. Yeah, that's that answer someone had. Do you have to write in standard form so you can get that answer? I think, John, you asked that. Yes, because then if you multiply it again, you could still get standard form if you put it in standard form the first time.
So you multiply 5 in a second by each of the 3 terms, and then 2a.
Yeah, let me show you with. I'm going to do it with a lot of colors, and I know that might be confusing, but maybe that'll help some. Sir?
So for the distributive property, so you do the distributive property the first term to all the other ones?
Yeah, and again, what you could have done is, what if you switched this polynomial with that one? You could still do it. You would take this one times all 3, that one times all. So you could do it either way, but yes, this way for now.
Oh no, that's.
I don't know if when you go flying, you see the little magazine or brochure that has like where that airline travels. Have you ever seen a map of where those, and it goes from here to here to here to here to here to here, and it's all these lines kind of like that, but way more jumbled up. But that's what's going on here. How many products am I going to get? 1, 2, 3, 1, 2, 3, 1, 2, 3. 3 times 3 is 9 of them. And they're based on those right there. So just be careful when you're multiplying because you don't want to multiply too many times or one too few, for example. Because then you did all that work for a wrong answer. Oh, and you are saved by the bell. We'll check this one out after lunch. Goodbye, Swivel. Oh, take a... You know that, Swivel?